Okay, we continue with the International A-Level Statistics S2 paper from January 2024, and this is question number 5. The random variable W has a continuous uniform distribution over the interval -6 and A, where A is a constant. Given that var W is 27, show that A is equal to 12. Since we are working with a continuous uniform distribution, we know that variance is calculated by A minus 6 squared over 12, and that's equal to 27 as the question says. So that gives us A plus 6 squared over 12 equals 27. So therefore A plus 6 squared equals 12 times 27. So that means A plus 6 squared equals 324. So this tells us that A plus 6 is going to be equal to 18, which is the square root of 324. So A is 18 minus 6, which is 12, as the question claims. So we've now worked out the value of A, and we know that it's equal to 12. So A is 12. Part B of the question says the random variable W has a continuous uniform distribution over the interval -6 to 12, where obviously A is a constant, so we've replaced A by its value, 12. Given that probability of W greater than B equals 3/5, find the value of B. So we know that the interval is -6 to 12. And the probability, so for part I, probability of W being bigger than B can be worked out by calculating 12 minus B over 12 minus 6. And that is going to be equal to 3/5, as the question says. So from here we have that 12 minus B over 18 is equal to 3/5, and we use a cross product, and that gives us 60 minus 5B equal to 54. So we have 5B equal to 6, and therefore B equal to 6/5, which is 1.2. And that's the value of B, 1.2. So part II says find the probability of W being between -12 and B/2. So now we know that the value of B is 1.2, therefore we have to calculate the probability of W between -12 and B, which is 1.2 divided by 2, which gives us 0.6. And that's what the question wants. We notice that the intersection of the interval -12 and 0.6 and -6 and 12, as given in the question, is minus 6 and 0.6. So that means that the probability that we need to calculate is going to be between the probability of W being between -6 and 0.6. So again, to calculate that, what we do is that we say 0.6 minus -6 over 12 minus -6, and that gives us 6.6 over 18, which is going to be 11 over 30, or we can write it as a decimal, and that's 0.367. Part C. A piece of wood AB has length 160 centimeters. The wood is cut at random into 2 pieces. Each of the pieces is then cut in half. The 4 pieces are used to form the sides of a rectangle. Calculate the probability that the area of the rectangle is greater than 975 centimeters squared. So we have a piece of wood AB, which has length 160 centimeters. Then the length AB is cut at a random point, let's say here, point X, into 2 pieces. So we get a length X here and a length 160 minus X. Then each of these pieces is going to be cut in half again. So they're cut in half, therefore we get the length X over 2 here and the length 160 minus X over 2 here. These 4 pieces are going to be used as the sides of a rectangle. So this length is X over 2 and this length is 160 minus X over 2. So we want the area of the rectangle. The area of rectangle is X over 2 times 160 minus X over 2. And we want it to be greater than 975. So we simplify this and we'll get 160 x minus x squared over 4 greater than 975. We multiply both sides of the inequality by 4 and we'll get 160x minus x squared greater than 3,900. So we rearrange the inequality and we write it as x squared minus 160x plus 3,900 less than 0. So this is a quadratic inequality for us to solve. We first find the critical values. The critical values are going to be x equal 30 and x equal 130. So we then do a sketch of the graph. Which is going to be, so that's 30, that's 130, and we know that is a quadratic graph, so it looks like this. We want it to be less than 0, so that means that we look at the part of the graph below x-axis, So that means that x has to be between 30 and 130. So then the probability of x being between 30 and 130 which is the probability of the area of rectangle being greater than 975 is going to be 130 take away 30 over 160, which is equal to 5/8.